Hello students, today I am going to teach Standard 8 Physics, Chapter 9 Energy, Part 3. During our first two parts, we had discussed regarding work and the energy need to do the work and different forms of energy. Here we will discuss more in detail about energy with different forms. That energy stored or in action, that we had discussed. Energy in action means energy in motion, that is the kinetic energy, and energy stored means in the form of potential energy. So energy can be found in different forms as energy stored or when the object is in action. Let us discuss with some examples like chemical energy, that is stored in atoms and molecules of all the substance like the food we eat or different petroleum products. Each substance is matter is made up of atoms and molecules, and they possess chemical energy. Magnetic energy, magnets. Magnet possesses magnetic energy within it. It possesses the energy because of which it possesses the magnetic properties. Nuclear energy, nucleus of an atom possesses the energy that is known as nuclear energy. So all these are stored form of energy. Stored form of energy means potential energy. So the chemical energy possessed by different states of matter or different substances, the magnetic energy possessed by the magnet, the nuclear energy possessed by the nucleus of an atom, all are stored form of energy. Those are type of potential energy. Next is light energy, that is when the object is in motion, that the photons are in motion. The smallest, because of the light, the particles, the smallest particle present in the photoelectric cell or some substance in which the particles gets energy from the light and start moving, start their action. So light energy at that moment, because of the motion of the photons, are the energy in action. So that is a type of kinetic energy. Heat energy, when we heat the solid state, it gain energy and the molecules start moving. When we heat any gaseous state or liquid state, the molecules gain energy and starts randomly moving. So heat energy is also when it is in motion, the molecules are in motion, it will give action to the molecules. So that is in the form of kinetic energy. Sound energy, sound is produced because of the vibration of a body. So these are the energy forms in action. So all these are the energy possessed by the body, light energy, heat energy, sound energy, in the form when they are in motion or in action, they possess kinetic energy. As you must have heard about the law of conservation of energy, that energy neither be created nor be destroyed. It can only change from one form to another form. And in an isolated system, some of the energy of all kinds remains constant. Isolated system means when there is no loss of energy in any system or while doing any work. So the sum of the energy of all the kinds, maybe at a time we are giving heat, so that converted into kinetic energy, and that again stops, then converted into the stored form of energy, that is into the potential energy. So different forms of energy present in an isolated system gives total remains constant. Whatever the energy being given initially, that is not going to be destroyed, or neither the more energy being created. The sum of all the kinds of energy remains constant at the end in an isolated system. So let us understand that energy conservation for a simple pendulum. What is a simple pendulum? A rigid support, a thread, flexible string with there is a metallic bob is there. When it is simply there is no movement, it will be at its mean position. Now the pendulum is being taken at either of the extreme positions. At B is one extreme, C is another extreme. So when the pendulum starts oscillating, it is being taken to one of its extreme, like say at the position C. So here it possesses the maximum height or more height than compared to the mean position. So at its extremes only it possesses potential energy stored due to the gravity or force of gravity of earth at some height. At the mean position, it possesses the maximum kinetic energy and minimum potential energy. While it starts oscillating and moving from mean extreme to mean position, its potential energy gradually decreases and kinetic energy gradually increases. Because it starts its action, so when the object is in motion, it possesses kinetic energy. So gradually kinetic energy increases and potential energy decreases. So mean position, kinetic energy maximum, potential energy minimum. Then gradually it moves to the another extreme. Its kinetic energy will decrease gradually and potential energy will increase. This process continues and sum of all the potential and kinetic energy will remain constant for the whole isolated system, means there is no loss of energy. Now let us discuss about another example, that is in a roller coaster. You must have get a ride in a roller coaster that at the top, when we are at the top, we are at maximum height against the gravity. That time the object or the roller coaster possesses the maximum potential energy. And when it comes to the bottom, when it is in full motion, it possesses maximum kinetic energy. Radially from top to bottom, again to top, again to bottom, there is a frequent change, radially change in, or where the energy varies from kinetic to potential, potential to kinetic, maximum height, maximum potential, minimum height, maximum kinetic energy. So sum of the potential and kinetic energy remains conserved or constant throughout the process. As we had discussed, that energy being used in any isolated system remains constant. Sum of all the forms of energy remains constant. Means the work being done by the roller coaster or by any other work or the simple pendulum to oscillate, that is equals to the energy change in the body. What type of energy change we had observed now? That gradually in simple pendulum potential energy changes gradually to kinetic, then kinetic again to potential. So the increase and decrease in energy. So let us take another example of freely falling body. At the top it is at maximum height, so it possesses at the top maximum potential energy. As gradually it allowed to fall in the middle, where it possesses both potential as well as kinetic energy. Here there is a decrease in the height from the top, but still it is at some height in the middle position, so it possesses both potential and kinetic energy. And at the bottom it possesses the maximum kinetic energy. Thus, a freely falling body, during a free fall, the energy possessed by the body at different positions. At the top, the energy possessed by the body. When in the middle, the energy possessed by the body, potential and kinetic. At the bottom, kinetic energy. At all the positions, the energy is conserved or constant. So, the work done by the body, energy change in the body in an isolated system is constant. Now we'll discuss the another fact of energy or the work done. If work is being done, Must be there that some time is also being taken to complete the work. So the rate of doing work means the work being done in unit time gives the power of that particular machine or who is doing that particular work. So power is equals to work done by time. The unit for work is joule, the unit for time is second. So joule per second is watt. So the SI unit of power is watt. That can also be represented as capital W. So how we can define 1 watt? 1 watt is equals to 1 joule work being done in 1 second time. 1 watt is that much amount of power for that particular machine when 1 joule of work being done in 1 second time. When power is greater, if work is more done in less time. When power of the machine is more. When we can do more work or the machine can do more work by taking less time. When the work is less being done in more time, the power will be smaller. Now we will discuss about difference between energy and power. Energy is the capacity to do work, the ability to do work, how much energy the body possesses, that much work it can do. And the energy being used to do that work in a given time is the power. So energy does not depends on time. The capacity it has, that much work it will do. But power depends on time because how much energy is being used on the given interval of time, that will give the power. The SI unit of energy is joule, the SI unit of power is watt. Energy can be stored. We had discussed that stored form of energy is known as potential energy, but power cannot be stored. It is the energy that is being utilized by the body in a given time to do that work. So it cannot be stored.